Good afternoon, everyone. My name is Luther from Group 25 Marlians. These are my group members, FA, Robert, Michael, and Ade. And today we'll be talking about the Intelligent 2D chess game. Introduction and motivation. For Marlians group project, we decided to create a chess game application such that two players can play against each other. This game involves a basic rule that each piece moves according to its valid moves on an 8x8 checkerboard. The main incentive behind this project was to provide a user-friendly form of entertainment to engage our minds during the lockdown period and provide distraction from constant activity on our phones. Tools we use, we wrote our code in Java and used GitHub as our code repository to share and keep track of changes. Most of our other research on the game came from Wikipedia and various chess websites. I'll be passing it on to FA to talk about the board and pieces.
Hi, my name is Efe, and I worked on the board and pieces for the game. So for a basic board, we start with creating 64 empty tiles and we add them to a board. This gives us an 8x8 chessboard format, and each tile of the board is indexed from 0 to 63. This helps us define the position of the pieces on the board once we start to populate it. We then set basic rules for the game, such as every board must have black and white pieces, therefore only 2 players. Every player must have a king throughout the course of the game. Each alliance must have only 16 pieces. An alliance is either black or white at the start of the game, so there should only be 32 active pieces on the board at the beginning of every game. We cannot have less than 3 active pieces, on the board. And in chess, we have 6 different pieces. We have the pawn, the bishop, the knight, the rook, the queen, and the king. Each piece behaves differently on the board and they have different movement patterns. So we moved on to define those, and Michael is going to talk about that.
Hello, my name is Michael, and I talk about the play and movement and how the game works. So making a move on the board that we created is basically materializing a new board into existence. So when a move's made, it doesn't retain the existing board being seen, but it brings a completely new board with the updated moves in it. So for example, like if you make a move with your pawn, it's not that same board you're seeing. For example, picture like a new frame coming in, but with your updated moves. And with that board that just came in, it's already checking all the legal moves that could be made for the next play. So like now we use this image on the right to explain the movement. So in the picture right now, the rook is on tile ID 35. So if the rook moves up, we go -8 positions, or from there we go down, it's +8. So I'm going to pass it to Ade to explain on how he made the graphical user interface.
Hi, my name is Ade, and I'm talking about the GUI. Firstly, we had the game history panel in which we created a tabular version of a scroll pane. We implemented a move history function, which saved the previous moves each player had made and displayed it on the right-hand side of the screen. On the left side of the screen, we have the taking pieces panel. For this panel, we created an array for each player called the white taking pieces and the black taking pieces. We had an isAttack function for each of the arrays, in which if a player made a move and took the other player's piece, it would be displayed either on the north side of the taking pieces panel if it was a black piece taken, or on the south side of the taking pieces panel if it was a white piece taken. Next, we have the game board panel. For the game board panel, we basically just use the chess idea of a tile holds pieces and a board holds the tiles. So in total, we have 64 tiles on the board, just like a regular chess game. Lastly, we have the highlight Lego moves. We created this to give a player an idea of where they can move each playable piece. So basically, when a new game starts, each Lego move is calculated. So when the user clicks on the board or on the tile, we use the tile ID to reference the piece, and each legal move that piece can play is gotten. To register user input, if the user clicked the right mouse, nothing, or we took that as no input had been made. But if the user clicked on the left mouse, then we took that as the user trying to make a move. Next, I'll pass it to my GUI partner, Robert.
Hi, my name is Robert, and I was the member responsible for designing the GUI of our chess game. This GUI includes a start game button, an options button, and an exit button. By clicking on the start game button, the user is directed towards the chessboard. In this chessboard, we have a preference menu, which is used to adjust functionalities towards the user's taste. This preference menu has 4 functionalities, and they are the highlight legal moves functionality, which was explained by Ade in the last slide, the refrain functionality, which is used to customize the size of the chessboard. We have the change piece art, which basically customizes the piece of the art of each individual piece, and the change tile color, which we use the JavaScript function to do. In future iterations, we plan on improving the refrain functionality and the change piece art functionality. We also plan to implement the use of timers for players to be able to time themselves during each turn. Lastly, we'll be adding a game setup component to the options button. Now I'm about to pass it to my group member Efe to continue the presentation.
Okay, so for the AI, chess is a zero-sum game. This means that every positive move I make is a negative move for my opponent. And so we went through a bunch of game theories for zero-sum, and we ended up with the mini-max. And in the mini-max, we just have 2 players, and one player is assigned the minimizer, the other player is assigned the maximizer. The job of the minimizer is to pick the move that would give the smallest possible outcome, and the maximizer's job is to pick the move that will give the largest possible outcome. And so for this, when we run the Minimax AI class, we give it a depth. So the depth here is 5, and this is just a bunch of nodes. And so we're coming from the bottom up, and it just searches. So the positive infinity here is the maximum move, and the minus infinity here is the lowest possible result you can have. And so we're going to pick the minimum from here. The minimum between these two is 10. The minimum is 5. We go up, we have to pick the maximum. The maximum here is 10. We'll just leave this side for now. We go up again, we have to pick the minimum. The minimum is minus 10. And then we come here, we have to pick the maximum, which is minus 7. So the AI calculates all these moves, and then let's say white is max and white is max and black is min. We're going to go this way. So the white is going to pick this way because this side gives the highest value of the 2. So the white picks minus 7, and then black takes up from here and continues. So next we have Luther to add the conclusion.
So as you can see, this is our UML diagram, the sequence diagram showing how the game of chess works. So for our future plans, we plan to improve the AI to allow more difficulty, which is, for example, beginner, intermediate, and grandmaster. We plan to improve for future iterations to improve and upgrade the GUI. For example, the graphics. We can be adding labels to the side of the board. For example, like A, B, C, D, 1, 2, 3, 4, etc. For the AI and game control, we can also plan on using the pause and continue the game, a button to pause and continue the game, and the ability to have different users with different records and different game files saved. GUI that you use to make the board color change for more efficient pre-made colors, pieces, combinations. For example, we use metallic, which metallic is 2 colors, blue and silver. And that will wrap up our presentation for today. I'm Luther from the Marlins Group 25. Thank you.